This video is on matter and potential and kinetic energy. Matter has mass, anything that has mass and takes up space. A substance is any specific type of matter. The three states of matter that we will talk about a lot in this course are solid, liquid, and gas. And we will look at the atomic and macroscopic scales. The atomic scale is something you cannot see with your own eyes, and we'll talk about how the atoms are moving. And the macroscopic scale is stuff that you see in your everyday life. If we are looking at our three states of matter, solid, liquid, and gas, on the macroscopic scale, we are very used to dealing with solids and liquids in our everyday life. Gases are all around us, and we need them to survive, but because we cannot see most of them, we are not as familiar with them. On the atomic scale, it is very important to note that the particles in a solid are very orderly and arranged. You can see here that they're packed in tightly. The particles move very slowly. They actually more vibrate. The particles vibrate in place in a solid. In a liquid, the particles are moving, or a lot of times you'll see gliding slowly. And they're considered fluid. Interestingly enough, gas particles also move in a fluid manner, but they move the fastest. They are in rapid, random motion. They are the least orderly out of the three states of matter. Some vocab words that go along with energy. So what is energy? Energy is the capacity to do work. What is work? Right here, pushing someone in a wheelchair is work. It's the act of moving an object against an opposing force. So the opposing force in this picture is friction, the wheelchair being on the ground, and gravity, of course, pulling the wheelchair towards the ground. Your two forms of energy are kinetic and potential. We will start with kinetic energy. When you think of kinetic energy, you need to think of motion. So on a macro scale, a moving car has kinetic energy. On the atomic scale, any particles in motion have kinetic energy. We just got done saying that all particles are moving. We know that solids don't move very fast, they more vibrate in place, so they have a much lower kinetic energy than particles in the gaseous state. Temperature. Temperature is the measure of the average kinetic energies, the energy of particles of matter. So if we think about this, let's think of water, for example. So if we have a high temperature and then a low temperature. So water at a very low temperature would be ice, right? It would be solid ice. Water at a middle temperature would be liquid water. And then water at a high temperature would be water vapor. Water vapor is obviously in the gaseous state, and we said that gas particles move very fast. So putting these two concepts together, we can see that particle motion and temperature are directly proportional, meaning as you increase the temperature, kinetic energy will increase. And then on the flip side of that, as temperature decreases, kinetic energy decreases. Heat is kinetic energy transferred from matter at a higher temperature to matter at a lower temperature. Very important here is that heat flows from hot to cold objects. So if you've ever held the refrigerator open too long and someone tells you you're letting the cold out, technically they are incorrect. I would not advise telling them that in the moment, but heat is entering into the refrigerator. The cold is not leaving the refrigerator. So heat is always moving from hot to cold. The next thing is potential energy. You can think of potential energy as stored energy. It has the potential to do something. So if you look at the picture here, this boulder on top of the mountain has a very high potential energy. It has the potential to move very fast and very far. As the boulder starts to go into motion, that is when it's turning into kinetic energy. Remember, when you think kinetic, you are thinking motion. And then when it's on the ground and it's not moving anymore, it has a very low potential energy because it's not going to go anywhere, and it actually doesn't have any kinetic energy either. Something with high potential energy is very unstable. And you can think of this boulder as being unstable, right? It can move, has the potential to move very fast and hurt someone or do something bad. Something with low potential energy, the boulder in place at the bottom of the mountain, is stable. It's not going to do anything harmful. Fuel has a very high potential energy. Products of burned fuel have a low potential energy. So your fuel, you can think of the food that you eat. So the food that you eat, carbohydrates especially, give you the energy to do your daily routines. So they have a very high potential energy. Products of food metabolism have a very low potential energy. So they are opposite. Here are some questions to look at. There's 4 of them. It would be a good time to pause the video and think about these on your own. Going over them, how do the 2 states differ on the macroscopic scale? And we're looking at liquid water and gaseous water or steam. So if we're thinking on the macroscopic scale, liquid water always has a specific volume. So if I have 100 milliliters of water in a graduated cylinder and I pour that into a beaker, it still has the same volume. It's still 100 milliliters, but the shape of it will change. It will go from a cylindrical shape to the shape of a beaker. So specified volume, but the shape can differ. Gas, on the other hand, or steam, doesn't have a specific shape or volume. It can expand to fill its room. Now looking at the atomic scale, we know that a liquid's particles move slower, more slowly, than a gas's particles. The gas is the fastest moving, so they move very rapidly, very randomly. How does the kinetic energy of the particles differ? We know that gas has the highest kinetic energy. Remember, as temperature increases, kinetic energy increases. So gas would be the highest temperature, so it would have the highest kinetic energy. And then which state has a higher temperature? We just answered that. Always think in terms of water. That will help you. We are familiar with water for a lot of things, so that will help us understand these things. And the last slide here, we are saying if this is potential or kinetic energy. Again, I would encourage you to pause the video and try these on your own first. A compressed spring that is not moving, that has the potential to move. A windmill turning, that is actually moving, that is kinetic. Particles in the gas state colliding with the walls, they are moving, that is kinetic. A skier skiing down the mountain, again, he is moving, that is kinetic. Pasta prepared for a meal, this is your fuel source, this is your carbohydrates. This has the potential to give you energy if you eat it.